Okay, one of your objectives in this unit is to distinguish between electron domain geometries and molecular geometries, or sometimes they'll be called shapes. So, what's the difference? Electron domain geometries take into account everything that's there. They just describe the geometry where everything goes. Lone pairs, single bonds, double bonds, triple bonds. What is the geometry where each domain ends up going? A molecular geometry, on the other hand, basically says, yeah, but I can see atoms, I can map those out with things like X-ray crystallography. If I just look at the atoms, even though lone pairs are still there, I can't see them. If I just look at the atoms, what do I see? Okay, so it pretends that the electron pairs, the lone pairs, are like ghosts. They're still there. They're still taking up room and they're taking up space, and those lone pairs are affecting the geometry, but it's like they're invisible. What's the shape that's left over if we ghost something out, if we have lone pairs? Let me give you an example. Let's say you had a trigonal planar electron domain geometry. You have a molecule here that has three things attached to it. Well, let's say that one of those things was a lone pair. Okay, so if one of those is a lone pair, imagine that this right here, this lone pair, is like a ghost. Pretend that it's invisible for a moment. What we see is not a flat triangle if we just focus in on the atoms only. What we see is still 1, 2, 3 things. Now, those 3 things here are not a flat triangle. Instead, it's 3 things that are not in a line. That line has been bent. We call this shape bent. Instead of having a flat triangle, I took that away. That's not the molecular geometry. I now have 1, 2, 3 things, but your 3 things are not in a line. Your line instead is a bent structure. So in the videos below, I'm going to show you what each of those electron domain geometries turn into. And the shapes should be logical if you know how to draw them out. So watch those videos below and we'll go through each of the electron domain geometries.